I'm not going to be showing you exactly how Vue renders, basically what renders what. Going back and forth between the applications and really seeing the lighting, anti-aliasing settings, and how a lot of the different textures will work. Also some different techniques to avoid flickering. I also want to make a note about the incorporated scene. Now, I did close out the application and reloaded the scene because I needed to make some changes to my video card to make sure that I was not anti-aliasing or oversampling the proxies or the billboard previews for the ecosystem to improve the overall display quality, which did work quite well. If you are a NVIDIA user, you can go to your properties, settings, and Vue does like a gaming card, so I'm just using a gaming card on this system. But what I went ahead and did was set up program settings, and anti-aliasing transparency is turned off. And then I've got my texture filtering set to high performance. And vertical sync is using the application setting. Triple buffering is on. Threaded optimization is on. I've got it set to single display performance mode. So I'm currently limiting this to one monitor. Normally work with a couple, but right now, just to improve the overall scene response while recording, I've got this set to single display, and the anti-aliasing to 8x Q. But the main thing is anti-aliasing transparency off, and the texture filtering, adjusting these options. You can also turn off the anisotropic sampling to improve performance a little bit more, really depending on certain situations. But those settings do help out quite a bit. Vue standalone does tend to like gaming cards better than the high-end cards, which is unfortunate. But that's because of the way the OpenGL is. It's a little more similar to a video game than your typical 3D application. So that's mostly when you're working in standalone. But taking a look with the incorporated scene, one thing I noticed was that even though my options were set for having the incorporation off, without having relative to the LIghtwave content folder checked on, when I saved the scene, it reset the xStream option and automatically incorporated the scene. Even with that option checked on, there can sometimes be problems. So one thing I suggest, if you're going to be separating these scenes, as I am, tends to be one of the better ways to avoid any serious production issues where you can corrupt your entire scene, is to, when you're finished working with the Vue section, go to File and save your scene. So you're saving the Vue scene. I also want to note that anytime you have an ecosystem populated, it will increase the size of the file. If you haven't painted any part of the ecosystem in standalone version, one thing you can do is clear the ecosystem population from the material, save it, and it'll be a much smaller file size. So then when you reopen the scene, you can just repopulate it. With dynamic population, it just ends up automatically clearing everything out and reloading only when you render. So once you save the Vue scene, what you can do is go to File and Close, which is going to close out every aspect of the Vue scene, removing the environment, volumetric, cameras. Just close out the plugin completely, and then you can save the actual scene. Because one thing that was happening was when I was saving the scene, it was also saving the proxy objects as well. which in this case it's no longer showing, but I had a null object created for every terrain because it saved out the proxies, which could not be called upon again and end up with some duplicates. So it is a good idea to close the view scene first and then save just the LIghtwave scene to really make those independent. Every version of xStream works differently with the different host applications, and I've been working a lot with xStream in Cinema 4D, which that's currently not an issue. In LIghtwave, that is something that does need to be separated. And there's another thing I want to mention too, and that has to do with the way the camera was set up. Going back to the view camera, which is the main camera, all of the settings I made are gone. They reverted back to the view settings, and even the motion option setup for the link is gone. So using the follower was very useful to just line up the camera to the existing camera in the scene, but to continue that link and use that other camera is not going to be reliable enough. So switching over to the view camera and then using that as the primary camera, animating it as the main camera, and not relying on the other one. I also want to note that any animation made with the view camera, and basically that's only going to show within LIghtwave. Once you open the scene in the standalone version, the animation is not there. So what you would need to do is go to File, and you can export animation to view scene. And if needed, there is also a plugin that comes, additional plugin that comes with xStream. Is typically used for Vue Infinite users that don't have the xStream integrated plugin, but it's very useful for matching lights and cameras. And that is the Synchronization Plugin. You will find the Synchronization plugins either on the installation CD or DVD if you have the hard copy. If you downloaded it, once the archive is extracted, which is what I'm showing right now, it should be set up the same way for the CD. There's a plugin called Synchro Plugins. So I'm going to go to Windows, LIghtwave, 9.0 64-bit, and this is the Vue Sync plugin. So you can load that plugin in. If you don't know how, first what I'm going to do is go ahead and copy it, and we're going to move this over to the LIghtwave folder. And in the LIghtwave folder, go to Plugins, and I'm going to go ahead and paste the Vue Sync plugin just into the main plugin folder. So we can go over to User tab, add a plugin, and then go back to that plugin directory. Choose Vue Sync, open, and now that's added into the scene. Open up Vue Sync, and this will work anytime the standalone's open. If you are using Infinite, it'll also work with Infinite. Basically, Infinite and xStream are the same program, just without the integration plugin. So within the standalone version, I'll just go ahead, and one thing you can do is open xStream, and as a version 7, you can open multiple instances of Vue, which is pretty nice. So now I've got the standalone open, and if we go to the main camera, and there's the motion tab, the animation tab, which is in the upper right here, you can go to Motion and select Synchronized. And we do need to go back over to LIghtwave, export the synchro data of whatever we want. So we can select cameras, sunlight, any lights or cameras in the scene, basically. Export the data. And it might be because I do have the xStream version open. Okay, and so instead of exporting, I just clicked on the synchronize, and it automatically updated. And when I go over to the standalone, it says a new synchronization file is available. Would you like to load the data? And click yes. So now, even though this is a different scene, the camera is matched up. And if we look under the Motion tab, under Synchronized, we can synchronize it to the sunlight or the main camera, render camera, grab the sunlight, and set up the sync data to that as well. So that way you can have all of these multiple files linked to the same camera settings, and that's pretty nice. Also, the animation is exported, and you may have to change your frame rates. So if you go into the animation render options, get it at 30 frames per second, and we do have a total of 90 frames in the LIghtwave scene. That's my default instead of 60, which is the normal default. So that is 3 seconds, and transferred over. So if we had any camera motion, that would also export all of the keyframes. So that is another available option. So even though you have the integration plugin, using the Vue Infinite Synchronization plugin is still really useful. You can also work back and forth between the programs, which is pretty nice. Okay, so let's take a look at the render options. So we're going to the Vue 8 xStream menu, go to Options, and click on Render Options. Now we have some extra options up on the top. The ability to turn off the rendering the atmosphere, the sky, and any objects in the scene, so basically the entire scene. So if you want to use xStream more like Ozone, which is just the atmosphere editor, just the atmosphere itself, you can turn off render objects and just render out atmospheres. Makes it a little bit easier. The post-processing filters, the natural film response filter. What this does is it takes the full dynamic range of the image and kind of breaks it down and makes a little more equal overall gamma for the render output. You can choose to use that or not. Depending on the way LIghtwave is going to render things out, you might not need it for the most part. It's something I usually only use in the standalone version. I don't typically use it within the integrated version. Under render quality, okay, the automatic mode is currently set, which is set by default, which is going to adjust the Vue render settings to be based on whatever settings we have within LIghtwave. So all anti-aliasing is handled, or at least all object anti-aliasing is handled entirely by LIghtwave, which includes motion blur, any advanced settings. The only anti-aliasing that is handled by Vue is texture anti-aliasing. So we're going to select Vue Render Options, which will give us the ability to edit and specify the quality settings. Anti-aliasing, you can see there's only texture anti-aliasing. In the standalone, you'll see a similar window for the render options, but it'll have object anti-aliasing available. This one's just for the texture. So there's a couple of different presets. Final render mode, used for stills typically. Broadcast, which can be used for animation. Superior and ultra. What these do and the differences are primarily to an increase in the texture anti-aliasing quality, and also the advanced effects quality, which includes procedural terrains and clouds, atmospherics, and is sort of a noise reduction. With the way the shaders work and many other effects, because Vue is entirely a volumetric that is rendering, even things like clouds are anti-aliased by LIghtwave because they are a volumetric object. The atmosphere itself is also anti-aliased because it is a 3D volume. If we switch over to the user settings, this will give us the ability to customize things more specific to our current needs. So we can go into texture anti-aliasing, and we can set our own specific setup. We can also choose to use the texture filtering. Texture filtering is a smoothing, and I'll go ahead and show you the difference. So we're going to turn on texture anti-aliasing and turn on the texture filtering. And I'm going to go ahead and render out a frame. Okay, so I'm viewing this at 200%, so it's very pixelated. So it's double the size it actually rendered at. I've got two frames I rendered out. One, this is with that texture filtering set to 33, which is the recommended amount, especially for animation. What it does is it basically is a mid blur in a way. It'll blur out textures in order to smooth them, and a lot of flickering is caused by the intersecting of polygons from highlights. Also, the way the alphas, unfortunately, a lot of them are in JPEG format, so the pixelation within there is creating transparency around the edges of the objects, which is also causing flickering. So the difference between the non-filtered version and the filtered version are very great. Also, the render time. The filtered version took about 2.5 minutes to render. I can double check. Render time was 144 seconds for the filtered version. And for the non-filtered version, it took 65 seconds. So twice as long. And for stills, it's not going to be something that's really necessary. You can just have a higher anti-aliasing. Really depending. The balance between the two, you really have to kind of play around with depending on the scene. Sometimes it's better, instead of using a high anti-aliasing amount, just to turn on the texture filtering. The main thing you need to be careful of when you're using texture filtering is primarily with plants. If you have a high amount of wind moving around the objects, the blur is sometimes so intense that the trees lose all their leaves. Now, if we take a look in the surface editor, and actually at the moment there are no trees loaded in, I'm going to go ahead, open the standalone just to show you one of the materials on the trees. So in the standalone, just a blank scene, I'm going to right click on the little plant icon, and let's go ahead and just grab the maple tree, which is one of the ones we're using. And we're going to switch over. Up here we can see the material in the aspect tab. We can right click, go to the maple leaf, and edit the material. So now we can see the color map, and then also there's a bump, and the filtering really helps remove the fine grain caused by this bump, because the bump will cause flickering. In some cases, it's better just to delete that bump map altogether, because it's just not needed for large-scale scenes. And then we can see the transparency. So we have a texture map connected to output transparency. It's controlling that. But the main thing is the color. If we take a look at the color, it's not an image where we have a white background and a separated leaf system. They're green. It's green in the background, which is the way, if you're going to be designing your own leaves, designing your own textures, they should be. Because once you start blurring those out, if you have white around the edges on the outside of the alpha, what's going to happen is you're going to see white material. It's also going to change. There's a calculation for every material, which is an overall color amount. So if you had a white background, it's going to modify the overall color, which also modifies the variation of ecosystem instances, because there is a built-in color variation applied to pretty much every ecosystem that's created. Now I want to just make a little note about the transparency. So if we take a look at the output for this transparency, overall it looks like we have some very fine lines, which is exactly what we'd want to see. If we take a look at the link rather than the actual texture, what we're seeing is a little more of a gradient fall off, and there is more of a transition between where it's being clipped out. What that does is causes a transparency at the edge of the surface. When other objects shine or show through that edge, it causes a flicker, and that happens in every program. So if you're having an issue with specific plants, especially some of these older ones, and with these very low resolution maps, low resolution is not always a bad thing, but how the image is saved can be. If we go over to the Links tab, these are saved as Prv Files, which is basically a kind of view file, something Vue will use for some of the content. A lot of them are derived from JPEGs, which can cause some problems. So if you need to, what you can do is clip out those ranges by selecting the link between that texture and the transparency output, adding in a filter, and now you can clip this a lot of different ways. We could set up a map filter. So our lower value would be -1, our upper value 1. And then we can adjust the input so that we're not using the full range of the image, but really, really reducing it to -0.1 and 0.1. So this way we're only taking a very, very fine amount from the image, clipping it out, and we should be able to see a pretty good reduction. Do you want to clip the out of range values? And sometimes it's not always going to show perfectly within the node preview, but we can even reduce this further just to allow a very small amount to get through. And that's going to help remove any of those in-between pixels. So it does give a much finer edge. Not using any of the image and interpolation methods also helps because every image has the ability to run interpolation, which is a smoothing of the edges. But if you have a somewhat of a gradient or more of a transition where you have grays and not just direct black and white, what can happen is it's going to create that edge transparency, which will lead to a bit of flicker. So one thing to pay attention to. So back in LIghtwave and looking at the scene, the lighting as well, we should take a look at. Ray tracing. Shadows are really well mixed between the two applications and processed per object. So if we have light rays casting shadows onto Vue objects, any shadow that's on a Vue object is rendered by Vue, and it's ray tracing. Any shadow showing up on a LIghtwave object is calculated by LIghtwave. And for the most part, that's pretty straightforward. Reflections working the same way, and also integrated back and forth because it is fully volumetric and pretty straightforward. And for ray traced lights, there really aren't any additional settings that need to be changed to modify or customize them. Going back to the texture anti-aliasing, if it is turned on for the scene, every object or every Vue material, we'll go ahead and select the procedural terrain, and we're going to edit the object material. And if we take a look, there is a TAA boost, which is the texture anti-aliasing boost. This is available for every material in the scene, and it gives you the ability to go above the settings defined in the render settings. So if you're having particular issues with a certain material, you can increase the texture anti-aliasing boost, or you can even decrease it. In some cases, you need to apply this to the top layer stack. Independent texture anti-aliasing per texture layer may not necessarily work. So if needed, if you're having any problems with it staying set, go to the top stack if you have multiple layers. And now this primary layer really isn't anything. Even the name itself doesn't show within the material summary. But it is sometimes in control of these settings up on top. So something to pay attention to. I'm going to go ahead and cancel that out and go to the render options. If you're going to be rendering animations, there's the enable motion blur and motion blur to object deformations, wind systems, things like that. And that's going to ensure that any motion blur calculations being performed within the Vue rendering will be applied. I also want to note that if you are rendering the scene through a transparent Vue object, the anti-aliasing is then controlled by Vue, since the ray tracing of that transparency is on a Vue material then. So I'm going to add an object to the scene. I'm going to create a sphere. So creating a Vue sphere, and we're going to go ahead and scale this up. And now the original scale it showed was 3 down here, even though I've just scaled it up. But the scale that was showing before was set to 3. I do want to note that it is half of the actual size. This would actually be created at 6 meters. Which is the typical size for Vue primitives. And I'm going to place this object in front of the castle, but so we can see both the object and the castle, and go ahead and take that sphere object. We're going to edit the object material, go to transparency, turn it up to, let's go ahead and use 83, and set a refraction index of 1.5, which is glass. Go to the Effects tab, turn down the diffusion amount to make it look a little bit better, and that way it's not going to be lit too much. And you can also see that the proxy material has updated for that transparency. And I'm going to go to the render options and make sure that texture filtering is off. I'm going to turn off texture anti-aliasing, set the preset render quality to preview, and render out a frame. So you can see a slight change in the way the object is handled because it is using different type of ray tracing. I'm going to go ahead and remove the intersection with the castle object, place it in front, go back and edit the object material, go to transparency and set the refraction index to 1, and let's just go ahead and increase the transparency up to 100. So if we take a look close up into the render, seeing where the intersection is, which is basically right around this larger round tower, the coloration differences in diffusion between the objects is not just from the smoothing. It does differ. So that sort of anti-aliasing, and we can see where the intersection is moving along the side, it does clearly change the look of the object. So that is one thing to keep in mind, that anti-aliasing through that transparent object may look different, and also the overall render output could look different. And it looks like I accidentally just cleared the wrong object from the scene. So I'm going to go ahead and reload scene from file. So going to scene, reload scene from file, and it's going to reload the view scene. So the LIghtwave scene will stay intact, but you can reload the view scene. So that's nice too. When you need to go to the standalone, you can go to scene, or this is the way I have it set up. Go to File, Open Scene in Standalone, and then after you save from the standalone, you can reload scene from file once you come back into LIghtwave. I've got a menu set up here for scene-specific operations.